I want to just make a couple of very quick announcements. Just to be sure we're all on the same page. This is really important. Number one, I had extended lessons 12 and 13 to the end of Thanksgiving break. I got a few emails this morning saying that they totally spaced doing it over Thanksgiving break. So, couple things that I'm going to say. I will not extend anything longer than this. Lessons 12 through 14 are due Tuesday, November 29th by midnight. Okay, so on the last day of class before break, we didn't cover a whole heck of a lot in lesson 15. If you were here or you were on the video, you may recall that there were a fair number of questions over lesson 12 and, you know, just figuring that stuff out. So I just took a breath and we went back and we really investigated lesson 12. If anyone's having difficulties on that section, I strongly suggest you refer to that video in order to get any additional information. Okay, so lesson 14 was already due tomorrow by midnight. Lesson 12 and 13 were actually due a while ago, and then I extended them to Sunday. Now I've extended them to Tuesday, but this is like it. Okay, so that is that. Worksheet or class activity, whatever the heck you want to call it, number 7 and 8 is also due tomorrow in class or via email. Okay, I won't accept them past that. I'm going to be giving worksheet 9 and 10 out this week. Okay, so please make sure you get that to me tomorrow. I got a bunch via email late last night, early this morning, but if you need a copy, it's on the Moodle page. If you are here, I have hard copies here, and I also want a hand test back and all of that stuff too, if you haven't gotten those materials back. So are there any questions about this? Yeah. Yeah. Yeah.
I don't know, but the cost function,
okay, so in terms of the cost function, remember our cost functions are made up of two parts. The slope is the marginal cost. So it's the cost to produce each item. And then B represents our fixed costs. So you'll notice in this example, you're given your fixed costs. So we already have C of X is MX plus 1,000. Okay. Right, because notice that follows, because if you set X equal to 0, the number of items produced is none, we're still going to have a cost of 1,000. Okay, so what we need to find is our slope M. Notice we're given that when X is equal to 50, our cost is 11,000. So then now we're translating it back to kind of like lesson 12, where, okay, we were given one of these pieces of information, and now we're given another piece of information so we can find the slope. So what I would do is I would say 11,000 is M times 50. plus 1,000?
Yeah, I was like,
Yeah, don't do that. Thank you for asking. Are you okay from here?
yeah,
Okay,
it's just getting to that point.
no pun intended.
Yeah, honestly.
Yeah. Thanks for asking. Yeah, so the reason why I've kind of extended a bit less than 12 is because, you know, it is just vitally important that you have those techniques because those are the techniques that we've been used throughout the rest. All right, well, what I would like to do is pick up where we left off in lesson 15. Okay, we are so close to being done with this entire course. We have lesson 15 online homework, which I have yet to assign, and then lesson 16 and 17 I combine into one. So really there's only 2 more open homeworks left, which is really sweet. And I'll talk more about, you know, tests and all of that stuff. It's on your syllabus. I don't choose when our final exam is. That's done by the registrar's office, but it's on the syllabus. And we'll talk more about that as we get closer to it. I will let you know that it is not a final. Again, it's just a 3rd test. So while I'll give you the full 2 hours because you have it, I'm only writing it to be an hour-long test. Yeah. Cool. Okay. So again, I'm picking up where I left off. My hope is that maybe you reviewed the notes a little bit. Otherwise, you're about to have like a little cold water on your face. You guys happy to be back? Okay, cool. All right, so what I want us to do is solve this system. Now, we wrote out all of the steps on how to solve this before break. Again, I'm not going to rewrite those, but recall what you want to do is our final goal here is to find an ordered pair XY that when you plug it in either one of these equations, you get equality. Okay. So the technique that I'm going to use is that addition elimination method. And recall the first thing that you do when you're doing this method is figure out which variable you want to get rid of. Okay, it ultimately doesn't matter. I mean, my MO is to do what involves the least amount of work possible. Is there something exciting in there? Ooh, okay. I thought it would be like a little party thing. Okay. All right. Well, anyway, so like if I look at my X's, I have a 5 and a 3. Okay. I need to multiply both equations by something. What do both 5 and 3 go into? 15. So do you agree if I had a positive 15 in one place and a negative 15 in the other place, I would be in business? Remember, our goal is additive inverses. We could also get rid of our Y's. Okay, notice I have an 11 and an 8. Well, both of those go into 88. So we could certainly multiply this one by 8 and this one by 11, and we'd be in business. Okay, I would probably choose to get rid of my X's just because 15 is a smaller number than 88. And I don't, yeah. That's my best reason. So what I'm going to do is I'm going to take my top equation and multiply it by a +3. And I'm going to take my bottom equation and multiply it by a -5. Recall, because in one of them, I want it to be positive and one of them negative. It doesn't matter. You could have done -3 and +5. So if I take my top equation and multiply through by 3, do y'all agree I get 15x plus 33y is -21? And in my bottom equation, if I multiply through by a -5, I get -15x plus 40y equals -125. If you have a question, you got to stop me. All righty. Now what we do is we add them up. What is 15x and -15x? Bye. They cancel out. What is 33y plus 40y? 73y. And -21 and -125 is -146. Well, pretty darn close. How do I get y all by its lonesome? Divide both sides by 73. And while these numbers look kind of yucky, you'll see you get y to be -2. All right, am I done? No, I need to find my corresponding value of x. So what do I do with this value of y? I take it and I plug it in either one of my initial equations to solve for x. Doesn't matter which one. Should we plug it in the top or the bottom? Top, okay. So I have 5x plus 11 times y, which is -2, equals -7. So 5x minus 22 is -7. I'm going to get 5x. Well, I'll add 22 to both sides to get 15. So x is 3. I will tell you that there's a problem like this on your last test, and you should get nice numbers like this, okay? So if you do the problem on the last test that I ask you to do using this addition elimination method, you're not going to get fractions or decimals. Okay, that's a great way to know whether or not you might have made an error on the way. Okay. So I want to do 2 more very quick examples. Recall that one of the things that we discussed when we're solving these systems is we're asking, where do the 2 lines intersect, right? So what we're doing is we're finding that point of intersection, and it's kind of sweet to do that when you don't have to graph. The thing is, we could also have parallel lines. And in how many places do parallel lines intersect? None. And we can also have the same line, okay? And if we have the same line, well, that intersects at infinitely many places, okay? Because there's infinitely many points on a line. So I want to show you what happens when we're in those situations, because so far everything's been solvable and we've gotten one ordered pair. Again, on your last test, I will not put you in the situation with parallel lines or the same line, just because tests are a timed situation and I don't want, your head spinning in an unnecessary way. Okay, but let me show you what it looks like. So let's suppose I have this system, 3x plus 2y equals 5, and 6x plus 4y equals 8. And suppose I wanted you to solve that system. All right, well, again, we need to figure out, who do we want to get rid of, x or y? What do you think? Y? Okay, so The consensus here is to get rid of our y's. So notice I have a +4 here. Do you agree if I had a -4 here, we'd be in business? So what do I need to multiply my top equation by in order to get a -4 here? -2. So if I do that, I'm going to get -6x minus 4y is -10. And I'm just going to rewrite my bottom equation because I didn't need to do anything there. What happens when I add on my left side? Well, what's -6x and +6x? Whoa, we didn't even mean to cancel that. -4y and +4y is also 0. So I get 0 is equal to -2. Well, what are you going to tell me about this statement? No, huh? It's an untrue statement. So when you get something that makes no sense, like 0 equals some non-zero number, this is when I claim that you have parallel lines. There is no solution. My recommendation to you, if you don't believe me that these are parallel lines, is to take each of these original lines and solve them for y. In other words, write them in the form y equals mx plus b. You'll see that they're going to have the same slope. Once they have the same slope, that confirms that they're parallel lines and different y-intercepts. Y'all cool here? Okay. So I just wanted to give you a taste of what that would look like. Now, suppose I give you this system. 3x minus 2y is -4, and -6x plus 4y equals 8. All righty. Well, who do you want to get rid of, x or y? Will somebody have some opinion, please? X. Thanks. I like opinions. So if we aim to get rid of x, notice I have a -6 here. Do you agree if I had a +6 here, we'd be in business? Well, what do I need to multiply my top equation by in order to get a +6 right here? 2. Right on. So if I multiply through by 2, I'm going to have 6x minus 4y is -8. I'll rewrite my bottom equation. Now what do I get on my left side when I add these guys up? 0. And what do I get on my right side? 0. Okay. Deep thoughts. 0 equals 0. Well, tell us something we didn't know. Okay. I claim when you're in a situation like this, it turns out these are the same line. Books call them dependent, but essentially there's infinitely many solutions. And I claim if you write both of these in the form y equals mx plus b, you're going to get the same thing. You with me there? Cool. All right. So the next thing that I want to do is as follows. A big portion of this last bit of stuff we have in lessons 15, 16, and 17 is translating word problems. Okay, so what I'm going to do is I'm going to jump to us translating word problems, because you'll see how in the end, we're going to need to solve a system of equations when all is said and done. Okay, so what we are going to do right now is get a fair amount of practice in translating word problems. Okay, And pretty soon, what we're going to do is we're going to see a need to use technology because our systems are going to get bigger than 2 equations and 2 unknowns. Okay. So let's take this example here. Suppose I tell you that a theater charges $8 for main floor tickets, and $5 for balcony seats. If all 600 seats are sold, and the total income is $4,200, how many of each type of seat are in the theater? You all have things over the weekend, or did you have a weekend off?
We had a game on Tuesday, and then. We're still here.
You were.
Yeah, well, I was on the Hamilton, my down. But we never left.
Yeah, and you don't get to leave over winter break either, do you?
Really 4 days.
Yeah. All right. So what I'm going to do is guide you through how to solve these things. Okay. So what I'm going to tell you is as follows. People, it tends to be a stumbling block taking a word problem in English and translating it to math. Okay. So what my aim here is to show you and give you some procedures with how to think about this so that when you're on your own, you know how to think about it. Okay. And set them up. So the first thing I'm always going to ask you to do is to define your variables. Now, what does that mean? That means the question you should ask yourself is, what are you looking for? And the way you know that is to go to the question that is being asked, right? Like that is your mantra here. Okay. Well, where are we? Here is the question that we're being asked. We want to know how many of each type of seat are in the theater. Y'all with me? Okay, like literally it's there in your question. So because I'm not original, I just use X and Y. You can use any letters you want. I'm going to let X represent the number of main floor seats. And I'm going to let Y represent the number of balcony seats. Do you all agree that this is what we were looking for? We want to know how many of each type of seat there are. Well, these seats are called balcony and main floor. Okay. Notice I don't say X equals main floor seats. I say number of. We're looking for a quantity, and that distinction is important. Okay. Any questions how I got this? Okay. Next thing that we want to do then is we want to set up our system of equations. Okay. So this is where it takes us deciphering all of this information that we've been given. Okay. And you're going to start to notice patterns with these as you practice more and more examples. Okay. So what sort of information are we given? Well, one thing we're given is money, right? $8 for a main floor seat, $5 for a balcony seat. We make a total of $4,200. Okay, so do you agree that one of them involves money? Probably going to want to keep money with money. And then the other piece of information that we're given is 600. In other words, the number of seats. Okay, you'll see that things break down in this way quite often. So let's talk about money first. Okay. Well, notice we have totals given. Okay, that's another way you can determine how you want to set each equation. One of them is, this is the total amount of money we bring in, and this is the total number of seats we have. Well, how much money do we collect from our main floor tickets? $8 per ticket times the number of tickets sold. Do you all agree? This should remind you of your revenue function from section 13. So I claim that the total amount of money we're going to bring in for our main floor tickets is 8x. How about for our balcony tickets? Okay, good. 5 times Y. Good job. Again, why is that the case? Well, we get $5 per ticket times the number of seats. And that's how we defined X and Y. Do you agree then for this one that we have the number of main floor seats plus the number of balcony seats is my total number of seats, which is 600? Well, what is the number of main floor seats? What are we calling that? X. What is the number of balcony seats? Y. And we've set up our system. Now, this is something we can totally solve, assuming we care. And I think that let's solve it. It's another opportunity to practice solving systems. So, who do you want to get rid of? X or Y? X. Okay. So if we want to get rid of X, notice I have a positive 8 here. Wouldn't it be great if we had a negative 8 here? And Chocho, you want to get rid of Y, then you would multiply the bottom equation by -5. In this case, we're going to multiply it by -8. You'll see that we get the same thing. So we have 8x plus 5y is 4,200. If I take my bottom equation and multiply through by -8, again, my goal is to get additive inverses. I'm going to have -8x minus 8y is -4,800. Got to multiply each term by that -8. All right, add them up. What's 8x and -8x? Cancels out. What is 5y and -8y? -3y. And what's 4,200 plus -600? I love this. Thank you. All right, how do I get y all by its lonesome? Divide by -3, and I get y to be 200. What did we just find? We did, but in the context of this question, what did we just find? We found that there are 200 balcony seats. We're not done though. Got to find our value of X. Okay. Now, what I would do here is I would totally use this bottom equation to find X just because there's less work involved. We found that Y is 200, so X plus 200 is 600. and we're gonna see that there are 400 main floor seats. Isn't that cute? Totally. Questions? Okay, let's practice more. And this one, we're just going to set up but not solve. Okay. So suppose a business produces ornaments. Suppose they make basic ones, whatever the heck that means, that take 20 minutes in the assembly department and 15 minutes in the painting department. And suppose they also make premium ornaments. Suppose those take 30 minutes in the assembly department, as well as 30 minutes in the painting department. Suppose I tell you furthermore, this business has staffing available for 3,900 minutes in the assembly department and 3,300 minutes in the painting department. If the business wants to fully utilize all staffed hours, how many of each type of ornament can they make? All right, I claim this is a totally realistic question other than premium and basic ornaments. In the sense of, you know, if you have a company that produces something, you want to use all your available people hours or minutes, as the case may be, so that you can make as many of your product as possible and then hopefully sell them. Okay, so this is an efficiency sort of question. All right, so again, the first thing that I always recommend you do, and I'll tell you to do this on your test, is define your variables. In other words, what are you looking for? And my hint is go to the question. Okay. It helps to do this because then you're able to break down all this gobbledygook information that you were just given. Well, what are we looking for? Don't we want to know how many of each type of ornament they can make? Sure am. So I'll let X represent the number of basic ornaments, and I'll let Y represent the number of premium ornaments. Again, you can do B and P if you want to, doesn't matter. Are there any questions as to why I defined my variables that way? Notice again, it's stated explicitly in the question. All right. For part B, all we're going to do is set up our system. We're not going to bother solving it. So by setting up the system, what we need to do is break down all of this other information. Okay, my hint to you is as follows. Just like my hint for defining your variables is to go to the question that's being asked, my hint for how you set up the systems are go to whatever totals you're given. And notice I'm given totals for an assembly department and I'm given a total for my painting department. Okay, so one of my equations is going to involve assembly department and the other one is painting. Note that follows from the previous because the totals we were given, one of them involved money and the other one involved how many seats. All right, well, let's talk about the assembly department. How much time does each basic ornament take in the assembly department? 20 minutes. So do you agree that the total amount of time my basic ornaments are going to take in my assembly department are 20 minutes per ornament times the number of ornaments?
Yeah.
And what about the assembly department for my premium ornaments? 30 times Y. Right on. So notice the assembly all hung out together. Now my painting is going to. Somebody tell me, how would I write out my second equation? Shazam.
Divide by -1 and try to get rid of.
Yeah, we're not going to go through and solve it, but you are totally welcome to go through and solve this. I hear you. All right. So one more to set up for today. And this is going to be so fun because it's going to totally give us our segue for tomorrow. You want to bring technology to class tomorrow. And by technology, I mean your calculator. All right. So now let's talk about an electronics company. So suppose I tell you that an electronics company produces transistors, resistors, and computer chips. I think I'd have more fun working at the ornament company. Suppose I tell you that each transistor requires 3 units of copper, 1 unit of zinc, and 2 units of glass. Each resistor requires 3 units of copper, 2 units of zinc, and 1 unit of glass. And finally, each computer chip requires 2 units of copper, 1 unit of zinc, and 2 units of glass. How many of each can be made if we have 765 units of copper, 385 units of zinc and 470 units of glass. Whoa, lots of numbers, huh? Okay, so the first thing that we want to do is define our variables. Okay? So, how do we define our variables? How do you define your variables? Don't you go to the question that is being asked? How many of each can be made? So, isn't it that we're wanting to find the number of transistors, the number of resistors, and finally, the number of computer chips? Notice that came straight from the question that was being asked. That's why I give you that hint. It is explicitly given. All right. Next, what we want to do is we want to set up our system. My hint for setting up your system is look at the totals. That'll tell you what each equation should be about. Well, what totals are we given? In other words, what are we limited by? We can't just make 1 million of each of these things because we're limited by the amount of the ingredients we have. So what is one total we're given? How about we have a total of 765 units of copper? What's another total we're given? 385 of zinc and 470 of glass. Do you see how I got these from the totals? So what that tells us is then that one of my equations is going to be all about copper. Another one of my equations is going to be all about zinc. And my other equation is going to be all about glass. Okay? So each transistor requires 3 units of copper. So my transistors are going to take 3 units per transistor times the number of transistors. You want to have each of these variables in each of these equations. How about resistors? Well, each of those take 3 units, so 3 units per resistor times the number of resistors. And how about my computer chips? Plus 2Z. Now let's talk about zinc. How much zinc does each transistor use? 1x. My resistors are plus 2y. And my computer chips are plus 1z. Do you see how I'm getting these? All right, then tell me, what does my glass equation look like? Tell me what to write with variables and everything. 2x plus 1y plus to Z. Would help if I could write in a row. Notice, I have 3 equations and 3 unknowns. So I'm going to say, oh my goodness. How do we solve this? Chomp, 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 chomp. Cliffhanger for class tomorrow. All right, thanks. Wasn't that a great way to end?